Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at graphing quadratic functions that are in standard form. We're going to work through two examples because there are two main ways that you can do this. So the first way is to take your equation that's in standard form, use the method of completing the square to get it to vertex form, and then graph from vertex form as we've done before. So let's recall how to complete the square. As long as your lead coefficient is 1, then we're going to just set up to add a constant after the x term to create a perfect square trinomial. To keep everything nice and legal and to maintain equality, if we're going to be adding a constant, we also need to subtract that same constant. Now, to get the constant that makes this a perfect square trinomial, we're going to take our b value, in this case 8, divide it in half, and square it. So 8 divided by 2 makes 4. 4 squared is 16. So the constant that I'm going to be placing into both blanks is 16. Now, we created that perfect square trinomial so that it would factor into x minus h squared. So here, this is going to be x, since this is a positive 4, plus 4 squared. And then we'll get our k by combining these two like terms. Positive 4 minus 16 is minus 2. So now we have h of x equals x plus 4 squared minus 2, which is in vertex form. So we can gather now our information about our vertex from our hk. So I know that's going to be opposite of the inside, so negative 4, exact on the outside, negative 2. Taking a look at my multiplier here, which in this case is a 1. Since that is positive, my direction of opening is up. And then my axis of symmetry is always an x equals vertical line, and it goes right through the vertex. So x equals negative 4. Placing that information on my graph, I'm going to start by graphing my vertex. Negative 4, negative 2 puts me right here. On a typical parabola, I can go to the right one, up 1, and to the left one, up 1. Since I don't have any multiplier other than 1, I can do the same thing here. So to the right one, up 1, to the left one, up 1. Now I've got my 3 accurate points. I can come in and using that same normal parabola shape, go ahead and connect through. All right, so that's method 1. Use completing the square to turn it into an equation in vertex form, and then graph from there. Sometimes, though, vertex form isn't super desirable because completing the square would be complicated. That might happen because you have a coefficient other than 1 in the lead, like we do here with a negative 2, or it can also be a little bit off-putting if our b value is odd. That makes completing the square more complicated. So what we can do in that case is use method 2, which says that we can get the h value, or the x-coordinate of our vertex, using the formula negative b over 2a, using that this is in standard form ax squared plus bx plus c. So for this particular equation, that would be negative 4, since my b value is 4, over 2 times negative 2, since my a value is negative 2. So that will be negative 4 divided by negative 4, or positive 1. So my vertex has an x-coordinate of 1. That also goes ahead and tells me my axis of symmetry is the line x equals 1. But in order to continue, I need the rest of my vertex. I need to know the y value. In general, we know that finding a y value can be done by taking an x value and plugging it in to our equation. So k, or the y value of my vertex, will be negative 2 times 1 squared plus 4 times 1 plus 1. So that's -2 plus 4 plus 1, or 2 plus 1 is 3. So my vertex has a y-coordinate of 3. Last but not least, we need to look for our direction of opening. That can be found from the very beginning, just looking at your a value. Since my a value is a -2, that tells me that I'm going to be opening down. And I'm going to note that I have a vertical expansion by 2 going on, and that is coming from that multiplier of 2 on my x squared. Okay, so let's get this information onto a graph. The first thing that we need is our vertex, 1, 3. So 1, 3, there's our vertex. Now we're going to be opening down. On a normal parabola, we could go right 1, up 1. So with the direction of opening down, we would go right 1, down 1, but we have this vertical expansion by 2. So we're going to go right 1, down 2 instead. Then using our axis of symmetry, we would go left 1, down 2. Now we have our 3 accurate points, so we can go ahead and connect through them using our good parabola shape. And there we have our graph for k of x. So if you get a quadratic function in standard form, you can either complete the square to get it into vertex form and graph from there, or use your x equals -b over 2a to get your vertex and graph from there. Alright guys, that does it for this video on graphing quadratic functions in standard form. We'll see you in a future one.